Hello friends, welcome to the second video on complex integration. We quickly recollect the formula which we learnt in our first video. The simple pole has the evaluation for integral over c f of z by z minus a dz as 2 pi I times f of a. You call it as, this is derived from your Cauchy integral formula. And for multiple pole, namely when z minus a is going to be taking some power, then the value of the integral is given by 2 pi I by n factorial f n of a. N stands for the derivative, so it's the nth derivative of a. We will quickly try to apply these formula to problem. The problem is evaluate integral over c cos pi z square by z minus 1 into z minus 2 dz, where c is going to be the circle mod z is equal to 3. We will have to first recollect, since the denominator is going to have power 1, it is going to be simple pole with f of z by z minus a into dz 2 pi I into f of a. The first point is to identify the pole. So on identification, the denominator equated to 0 gives us the poles. So z minus 1 into z minus 2 equal to 0 gives the values of the poles or the singularities. So z minus 1 equal to 0 gives us z is equal to 1 and power is 1. So this is a simple pole. Next, I have z minus 2 is equal to 0. This gives me z is equal to 2. Again, this is also of power 1. Hence, is a simple pole. So, I have find out what is going to be the poles of the given problem. What is the second step? Second step is to plot your boundary, which is given by mod z is equal to 3. So, what is going to be my mod z is equal to 3? I have it as modulus of x plus I y, which is going to be mod z equal to 3. What is this modulus to be? Root over real part square plus imaginary part square equal to 3. To remove the square root on top, what do? Is we square on both sides, making it as x square plus y square is equal to 3 square. This represents a circle with center. What do you think is the center of the circle? Over here it is no element and no y element, so 0, 0 is going to be the center. And what is going to be the radius? Radius is going to be 3 units. So this boundary is now plotted for. So we are going to draw a circle with center 0, 0 and radius 3 units. This is going to be a circle with center at 0, 0 and radius to be equal to 3 units. What is our next point? Next point or point number, this is my point number 1, this is going to be my point number 2, and now my point number 3 is to search for my poles. What are my poles? Z is equal to 1 and Z is equal to 2 are my poles. I can write Z is equal to 1 as 1 plus I 0. So this in representation with x comma y gives me 1, 0. 2 can be written as 2 plus I 0. So with representation to x comma y, I get it to be equal to 2, 0. Now we will try to plot our poles. Where is going to be our point? 1, 0, this 0, 2. So this center point is going to be 1. Okay, so what happens over here? I have my point 1, 0 to lie inside or outside. What do you think is going to be the value of the pole? The value of the pole, which is going to be 1, 0, is going to be inside. So I have this point to be inside. So this value lies inside. Now how about the second point? What is going to be our second point? The second point is going to be 2, 0. Where is going to be 2, 0? So we will try to plot this 2, 0 also. 2, 0 is going to be over here. So 2, 0 also lies inside. So we come to a conclusion that both the poles, which is going to be z is equal to 1 and z is equal to 2, lie inside the given curve mod z is equal to 3. So z equal to 1, 0. This is going to be 1, 0, my first pole. 2, 0. This is going to be 2, 0, the second pole. Both of them lie inside. So when they lie inside, what I'll have to do? I'll have to apply the Cauchy integral formula to evaluate the integral. So I will have to evaluate my integral over C cos pi z square divided by z minus 1 z minus 2 into dz. So I can notice that my formula in my Cauchy integral formula as f of z divided by z minus a into dz. So I have only one term in the denominator, but now you see over here I have been given with two terms. They are in product. So I cannot apply my Cauchy integral formula when I have it as product, in which case I will have to split my denominator into factors. How is that possible? I can do that by using the technique called as partial fraction method. So how will I split it into partial fraction? I can make it as a by z minus 1 plus b by z minus 2. Now you can see that the terms which were in product has now got separated like what we require in the denominator. Only single term will be there. Now our target is to find the values of a and b. I know that cos pi z square, now cross multiply a times z minus 2 plus b times z minus 1. How to get the values of a and b? Just equate your poles to, the factors to 0. So z minus 2 is equal to 0. Z is equal to 2. So when I substitute z as 2, I will have cos pi 2 square. So that makes it as 4 is a times 2 minus 2 plus b times 2 minus 1. 2 minus 2 makes it as 0. Cos 4 pi, even number of pi times of cos is 1. So that makes it as 2 minus 1. So it is 1 times of b. So that gives me b as 1. So I have got my value of b. How to get the value of a? Replace your remaining term, which is going to be the factor z minus 1 as 0. So z is taken as 1. So when I put z as 1, I will have cos pi 1 square makes it as 1, a into 1 minus 2 plus b into 1 minus 1. So 1 minus 1, this will become 0. So I have cos pi, which is minus 1, is equal to a into 1 minus 2, that is again minus 1. So I will have my a to b cancel off over here, a take the value 1. Now putting it back over here, I have this as 1 divided by z minus 1 plus b takes the value 1 divided by z minus 2. Hence integral of cos pi z by z minus 1 z minus 2 is the same as, how I can rewrite this problem now? Integral over a, which is going to be 1 divided by z minus 1 dz plus second integral for my 1 divided by z minus 2 into dz. So the problem which was like this has now been converted into a problem of this sort. Keep in mind, we used partial fraction because the terms were in product. We want only a single factor in the denominator. To make it into a single factor, we did partial fraction method. Now comparing it with the general formula, what do we know? F of z by z minus a dz is 2 pi I times of f of a. What is my first integral? 1 divided by z minus 1 into dz. What is my second integral? 1 divided by z minus 2 into dz. Now identify what is going to be in place of f of z. In place of f of z, I have it to be equal to 1. In place of z minus a, what do I have it as? I have it as z minus 1. So a takes the value 1. What is on my right hand side? Right hand side is going to be equal to 2 pi I times f of a. So what will be 2 pi I times of f of a? So f of a is f of 1. What will be f of 1? Do you have any z for replacement here? No. So f of 1 remains as f of 1. So it becomes 2 pi I times into 1. Now coming to the second factor, tell me again what is there in place of f of z. My f of z is going to be again equal to 1. What is there in place of z minus a? In place of z minus a, I have it to be equal to z equal to 2. Sorry, z minus 2. So what is in place of a? I have a to be equal to 2. So what is this quantity equal to? 2 pi I into f of a. So that has to be f of 2. What is f of 2? Replace z as 2. Do we have any z for replacement here? No. So f of 2 remains to be the same constant as 1. So this becomes 2 pi I times of 1. Hence integral over c cos pi z square by z minus 1 into z minus 2 dz, which was split into partial fraction using and got as 1 by z minus 1 dz plus 1 by z minus 2 into dz, takes the value 2 pi I times of 1 plus 2 pi I times of 1. So the final value is going to be 4 pi I. So keep in mind, whenever you have factors to be in product in the denominator, use partial fraction method to split them into single factors so that you can apply the Cauchy integral formula. Thank you.